Hi, welcome to my video on different ways of expressing the derivative. Number one, d over dx is the derivative in terms of x. And let's write the f of x equals 4x as the derivative in terms of x. So that's f prime x equals d of dx of the 4x. So that becomes f prime x, and the derivative in terms of x is a 4. And here we get the g of x, so the derivative in terms of x is, so there's the derivative symbol, g prime, and the derivative in terms of x is g prime x. Derivative of x squared is 2x. The derivative of the 2, which is a constant, is 0. And we got the t of x equals this negative 6x cubed plus x squared. So the derivative of tx is t prime, and this is d dx on negative 6x cubed plus x squared. So that comes out to t prime x, and the derivative in terms of x is 3 times negative 6 is negative 18, and the 3 goes down by 1, plus 2, and that's an x, and the 2 goes down by 1, so that's a 1 there. So this is d over dx is the derivative in terms of x. Now, if we just have an expression and we do the derivative in terms of x, that's the derivative in terms of x. The derivative of negative 6x is negative 6. Derivative of a constant is 0. The derivative in terms of x is 2 times 4 is 8, and the 2 goes down to a 1. And the derivative of 7x, that's a linear, so it's just a 7. And the derivative of a constant is 0. And the derivative in terms of x here is 2 times 4 is 8, and 4 becomes a cube. And here, the 3 times 7 over 3, 3's cancel. I get a negative 7x squared. Cubic becomes quadratic. And 2 times negative 5 is negative 10, and the quadratic becomes a linear. And we have the derivative in terms of x. We have 6, let's write this one down, 6 times negative 4 over 3, and the 6, take away 1 is 5, and the 3 goes into 6 too, so that's a negative 8x to the 5. So this d dx is the derivative in terms of x. Let's continue. Another way to do the derivative of is to find the derivative of y in terms of x. So we got, this is the derivative of y in terms of x. So it's called y prime. So when I do a d, which is the derivative of y in terms of x, d times y is, so it's a dy over dx, which is also denoted as y prime. So dy over dx is the derivative of y in terms of x, or it's the same y prime. So find dy of dx of each. So that's d of dx of the y, and it's d of dx of 6x plus 2. So I did the derivative of each side in terms of x. So that gives you dy over dx. And derivative in terms of x, that's 6x. Oops, sorry, my mistake. 6x is a 6. The derivative of 2 is 0. And again, the derivative in terms of x of the y, and the derivative in terms of x of x squared minus 8x minus 1. So that's dy dx, and the derivative of x here is 2x, and the derivative of a negative 8x is negative 8. The derivative of a negative 1 is 0. And we can also call this, go back here, dy over dx is also could be called y prime. See, so this is the derivative of y in terms of x. So when you see y prime, that's the derivative of y in terms of x. And here we have y equals 4, so it's d dx in terms of y, and d dx on the 4. So this is dy dx, and the derivative of 4 as a constant is 0. Or that could be y prime is 0, either or. Derivative of y in terms of x is 0, or y prime is 0. And d, it's the derivative in terms of x of the y. So we do this on both sides. Now, a lot of people don't write it down like I'm doing, but I'm making sure I explain it. So the derivative of y in terms of x is dy dx. And the derivative of this binomial in terms of x is negative 4. Negative 2 times 4 is negative 8 x cubed. And 6 times 3 is 18 x squared. So notice the quartic becomes a cubic, and the cubic becomes a quadratic. Goes down by 1. Find y prime of each. So y prime, another name for y prime, is dy over dx. So a lot of teachers will just, students will go y prime here and do the derivative here. But I like this. You don't have to, but I'm of habit. And when we go further in math, you'll find a reason why I'm doing this. So this is dy dx. Derivative here in terms of x is 3 times 2 is 6, and the square root 2 becomes a 1. Derivative of constant is 0, so that's the same as y prime is 6x. B, I get derivative in terms of x, derivative of y in terms of x, derivative in terms of x of the 1/5 x to the 5 minus 3x squared. So I did dx, d dx on both sides, so that's dy dx. And the derivative in terms of x, 5 times 1/5 is 1, so it's x to the 4th. And negative 3 times 2 is negative 6, and the square becomes the linear 1. And so that's dy dx, the same as y prime. So, almost made a mistake. That's an x. Okay, let's continue. And it says, find dx of this function. So the derivative of this function in terms of x is 8x minus 3 plus a 0. So 4 times 2 is 8, and the 2 becomes a 1. And this is a linear, so it's just negative 3 because the slope is negative 3. And again, that's a 1, so we put a 1 times negative 3, you get a negative 3. And 1 minus 1 is 0, and x to the 0 is 1. So you could write down d of dx like that, but that's, there it is. So you could have wrote down this first, and then this answer. But if you do the derivative, that's only saying do the derivative of this in terms of x. So there it is. Find the derivative of this. So the derivative is, again, is d dx of, so it's just saying the same thing, 7 over 2. So to find the derivative of this is find the derivative in terms of x. Notice it has to be in terms of x because it's all x's here. So d dx. So negative 2 times 3 is negative 6. X, 3 becomes a 2. 7 over 2 times 2 is 7. And then x, 2 becomes a 1. And find dy dx of this equation. So that's d dx of the y. And we do d dx of the right side. And so that's dy dx. And the derivative here in terms of x is 7 times 4 is 28. And 4 becomes a 3. 2 times 2 is 4. And the 2 becomes a 1. And the derivative of a negative 9 is a constant is 0. And let's find the y prime of this. And the y prime is the same as dy dx. So I do the derivative. I do d dx of both sides. D dx of both sides. So that's dy dx. And the derivative here, in terms of x, 5 times negative 5 over 3 is negative 3x to the 4th. Negative 4 times 3 is negative 12x squared. Derivative of 2x is plus 2. That's a linear, so just 2. And so we want to find dy dx, well, that's the y prime. Again, you could have wrote down, you could have did the derivative of this side, which is right here, and the derivative of y is y prime. But I like to do d dx on both sides. Just takes. You don't have to do this step. You don't have to do this step. You could just put y prime right there, because the derivative of y is y prime. But notice, this is why it is, and why it works. And there's the answer. So just different ways to state the derivative. And you'll see that in the videos coming in the future. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.